introducing me, and what I will be talking about is the name of the presentation is Beyond Embeddings towards Artificial Intelligence. But what it will be about is that nowadays it's really popular, the deep learning. This field is really fast evolving. It is really fastly changing, and it is really frequently used, I would say, buzzword. I will try to put that word as well into the context of the to the history, and as well what's coming and what this field is trying to do, and what the limit as well of that. First of all, where I'm from the Czech Republic. Czech Republic is a really small country. It has only 10 million people, so it's a half of your one city, I would say. But regarding where you should consider to visit this country, we are ranked in the top 10 for many years regarding the student city. As well, we are relatively known, and it is, I would say, not so far, more or less 6,000 kilometers. So looking forward that one day you will visit our country as well. The university I'm from is, we are the largest technical university. The capital city is Prague, the second largest city is Brno, and my university is the largest technical university. We are relatively research oriented, and as well we have cooperation with industry. The size of the university is that we have approximately 23,000 students, 8 faculties, 81 different study programs. And let me start about explaining and talking about the history of AI. When it started was actually with the very first computer. With the very first computer, which was really limited, especially when we compare that with the abilities of today, let's say smartphones, for example, they were pretty simple. The first question was given by Alan Turing, and he asked whether computers can ever think. After that, long time, I mean, many years didn't happen, nothing very special. The milestone of AI was in 1997. It was the first time when the professional chess player, Garry Kasparov, lose the match with the computer. The name of the computer was IBM Deep Blue, and it was the first time when on the professional level computers started to be better. After that, another milestone was 2011. It was not limited just to a game, but it was based on a question and answers. As well, the word deep learning is relatively well known. Not sure if everyone of you have heard about that, but right now it is maybe used even more frequently than it should be. After that, there was a brisk development of many different kinds of algorithms, including, for example, in 2014 was developed or proposed, it was by Microsoft, was a neural network that was able to outperform actually performance of human in recognition or classification of images. As well, in 2014, again, it was Microsoft that provided image annotation, and it was quite impressive. As you can see on that image, there is it can be seen that from this scene to describe that by computer it's a relatively difficult task, and by a human it was described as a group of men playing a frisbee in a park, and the computer can do that. The same, in a couple of milliseconds, described that a group of young people playing a game of frisbee. So that's really impressive to me. After that, there were a lot really some things that happened, and I will talk to them. Very important year was 2016. In 2016, the last go where a human was better in a desk game. The Go game was the last desktop game when a human was better than computer. From 2016, it is not true anymore. And from the 2016s, the computers and algorithms are being still getting better and improving. So another year, 2017, the computer won in professional game of poker. As again, this game is it is a skill game actually, not only hazard. Of course, everyone can lose a lot of games, a lot of money there. Anyway, it is being considered a skill game. And I was talking what will actually hopefully happen in coming years. Those parts that I described already happened in the last 70 years. The question is what will happen in the next coming years, and whether we are pretty close to develop something that thinks like a human brain, and how the computers and people differs. The question is whether there is a hype about artificial intelligence, and to be honest, there are every 20 years there is a cycle where there is overestimated capabilities of artificial intelligence. In 1970s, it was estimated that it is matter from 3 to 15 years to develop something that is of the comparable capabilities as human brain is. And this technology is being called AGI, or Artificial General Intelligence. Of course, it was not true, the prediction was wrong. Again, in 1983, it was predicted that we will develop such a technology in 10 years. In 2002, we predicted we will develop such a technology in 20 years, and almost for sure we will not be able to do that. And in 2018, we are predicting that we will be, as a humanity, will be able to do that from 7 to 80 years. What's the truth is that, unfortunately, all the attempts, there were as well attempts to completely reconstruct the brain from the microscopic level to simulate them in supercomputers. Unfortunately, all the attempts was not successful. So regarding the AGI, I would say we didn't on a track of development of such a technology. So the question whether there is a hype around AGI or artificial intelligence in general, in my opinion, that's true, and it's not only my opinion, as well Gartner, which is a consulting company, are telling that people are selling big dreams. When you compare what is being presented on the top conferences and compare that what is being presented on let's say startups, there is a big gap between those two areas are absolutely two different worlds. And what Gartner says is that they are usually selling dreams, and companies don't have the skills to understand what can and can be done, what can or can be done. General confusion about the capabilities can, unfortunately, slow down, and most probably will slow down the adoption, since this technology is really promiseful and has really nice potential. And this field is progressing really fast. However, it would be good to understand what is possible to do with the technology and what is not possible to do with the technology. Before I start, now I will be more concrete. I will be talking more in more details about the technical parts. Can I ask you, how many of you have ever trained their own neural network? Not much. Well, I hope there will be more people. Anyway, I will try to do some overview. What is the recent most significant changes in the field? And well, the transfer learning and the machine learning is being somehow overestimated, and some people are trying to use the deep learning in every areas. However, it significantly depends on amount of data, and some pretty old algorithms that were developed many years ago are even better. For example, if we are able to represent the data in Excel, Microsoft Excel, then the traditional algorithms will work very well. And it is not needed, actually, since it is really complicated to set up, to find the proper configuration. And on those topics and those tasks, the traditional algorithms will work much better in most of the cases. There is a second case when we have more data, and then it may pay off to use own neural network architecture to design our own architecture. And in case we have a lot of data, then it can pay off to use pre-trained models and to use some so-called transfer learning. So the deep learning is definitely not an answer to everything. Well, nowadays there are as well plenty works that makes easier to develop their own architecture, and starts from designing the parts of neural networks that can perform well. And this is to some degree automated, so we don't need to have spend time with it anymore. Regarding the transfer learning, behind let's say the deep learning area, the transfer learning is something that is one of the most important part of the success of deep learning in recent years, and in particular the image classification. From 2012, it was shown that the so-called convolutional neural networks perform very well, and there were designed plenty of different architectures. One of the very important was in 2015. It is called the ResNet. This neural network is outperforms actually the capability of humans, and is more accurate on the tasks of classification of images. From 2015, there was as well relatively fast development, and one of the top was introduced in December 2018, which is being called FishNet, and too performs pretty well, much better than the one that was introduced in 2015. Well, some recommendations, since most of the people from public didn't mention that they are using their own development. I will maybe skip this part. However, to create their own approaches, there are some recent developments that can help you to even take an existing neural networks, to put there the latest findings. And even with those approach, you can get easily relatively nice results. This really briefly. So what happened in recent years, and what is the deep learning, let's say, from those years 2012 to 2020? Regarding the object detection, there was a really strong development, and it can do, and in milliseconds detect and even predict what can be in an image. The algorithms that are behind are shown over there, and one of the milestones that was introduced a couple of weeks ago is being called efficient net. It uses significantly less computational power. It is significantly more efficient. However, at minimum, at the COCO, it is a data set for evaluation of object detection algorithms. It performs pretty well when compared to the other algorithms as well. There are some open source the implementations available on the internet. So in case you will be involved in an object detection task, I recommend you to consider as well this network, since it seems it is really promising for the coming years. As well, the deep learning is strongly supported by generative adversarial networks, so-called GAN networks, which was introduced by a good fellow in 2014. And from that, well, what you see there are artificially generated images. None of the people you see there actually exist. Everything was synthetically created just by neural networks. And the recent development there is SIGAN, and big GANs. And big GANs, what they can do are actually, for example, merging the similarity of a couple of people, or just by giving some insight what should be on an image. It can generate such an image that is relatively with high resolution, and there are no any obvious mistakes in that. The work of that is from Google, and the name of that network is being called Big. Again, they used as well significant computational power to achieve such a result. What is as well behind the deep learning is training. It's reinforcement learning algorithm. The reinforcement learning is something between supervised and unsupervised kind of learning. And interesting thing is that to train, it's a Dota 2 game. Can I ask you, is there anyone who is playing that game? Only few. Well, it's a strategy game. There are top human players, and as well there are some of the AI players. You can see them on that figure, and it is quite interesting that there is for the first position there is a significant, relatively nice prize money. It's more than $1 million for the first place. And in that game, there are competition to compete with artificial intelligence with human. I selected one of my favorite part of that game. Would like to say that everything was being learned from scratch. It was being learned just from self-play of the computer with computer, and just by playing with itself. In a simulated time, by the way, it took 45,000 of years since it was trained in parallel. It in fact got, if I'm right, around 3 months. For approximately 10,000 of CPUs was used for the training as well. For about 1,000 of GPUs was used for this purpose. However, the resulting algorithms is winning 99.4%, only 42 loses, and 7,215 wins when competing with the human players. And by the way, it uses only 20% of resources, and win rate is relatively nice, and those algorithms are still being improving. Now I will show you a favorite part. You can see on the figure that there are human players. They are denoted by age, and AI player. They are denoted by the red circle. You will see that those two AI players are fighting with a human player which are nearby. And the human player, one of them will try to hide in the tree and to get advantage. As you will see, the algorithms will lose focus with fighting with the human player, and they will start to try to seek for the one who is trying to hide in the tree. It's quite impressive, since everything of that was actually being trained without any human supervision. It was just being trained by self-play. So you can see there that now they are playing with a human player. Now they are trying to search for the one human player which is trying to hide in a tree. And the capabilities of that algorithms is getting better and better, and each year or every half a year, and they are introducing more and better algorithms that can do and perform better as well. To copy such an experience, it is pretty easy. It's if anyone, any human player would like to play such a game, it is years of training, I would say, to get to the first position. For a computer, it is a method of copying that algorithm in a seconds, and another computer can perform this with the same, let's say, accuracy, with the same skills as the previous one. Another work as well, very impressive, is from DeepMind. The algorithm is called AlphaStar, and this is another strategy. It's a one-on-one strategy, but pretty complex. You have to collect resources. You need to build soldiers. You need a different kind of them. Then you can have as well different kind of strategy as well. In that case, the AI is better than 99.8% when playing with the human players as well. There is quite interesting reward to be winning the challenge. And what is quite interesting as well, that the capacity and capability of computers is to do really a lot of actions. But the truth is that the actions is only about 20% when compared to the actions that is doing a human during the play. There are plenty of different applications, and there as well the e-health is a big topic, and in big topic and analysis of imaging or 3D images, 2D images, classifications of images. AI can be of big help with many contributions, and can assist to doctors to do better decisions. So what changed in the recent years? 18 and 19. Well, the quite popular neural networks are recurrent neural network. It means LSTM and GRU, and they are used for sequence modeling tasks like time series analysis, like audio analysis, and so on and so on. In December 2018, it was proved that so-called convolutional neural network performs actually better than the LSTMs that were proposed a couple of years ago. They have as well better memory, longer memory, and it was proved that better performance. It has better performance than the recurrent neural networks. Well, in 2019, there was a big question regarding neural networks, whether it is the most important how to set up the weights of the neural networks, or whether the structure of neural network is the most important. When compared to the human brain, they are much more, let's say, not so uniform, but connected almost randomly. However, in December 2019, it was published a paper. It is being called lottery ticket hypothesis. And the answer is to that question that optimal neural network structure can be learned from start, and it does not matter too much On the structure, it's just about randomly generating weights with the connections, and with that we are able to reduce significantly the amount of data that needs to be processed. So even the big and large neural networks can work, for example, on a smartphone or some IoT device. As well, it was introduced a new kind of layer. It is being called independent component. Why this is very important is that just by using and running the existing neural network, if you put there such a network, there is a high chance that you will outperform the previous one. Or I already mentioned the fishnet. It's one of the best transfer learning success in the recent years, and this network is devoted for the image segmentation. Well, one of the very important findings in December 2000, well, again published on the same conference as before, one of the top conferences in AI, and it was demonstrated that current convolutional neural networks, when compared to human vision, works differently. They work more on the texture than to try to recognize the shapes, and as it is demonstrated on the figure below. So one of the future of development should be how to improve to match the shapes, not so much just the textures, since it is easily to be confused that he thinks that the cat on the right side is actually the elephant just by switching different texture there. Well, the neural ordinary differential equations is a relatively nice extension of theory which is behind the differential equations and connections and matching the similarity with neural networks. And the big advantage is that they can be continuous and they can fast and generalize the information much better than, for example, the residual network, the one that performs in the classification of images, the human. It can be trained much better, and as well it succeeded this year in super resolution tasks. As well, regarding language modeling, the current state of the art is the transfer learning. It is quite impressive. If you can see the input, I just copy-pasted the name of the conference and that International Conference on Contemporary Computing in collaboration with, and so on and so on. And according to that, it was automatically generated text. It was generated by GPT-2. By the way, it was not released publicly for a couple of months since they were claiming that it is too dangerous to release. And what it can generate automatically without no any human supervision is a text that is relatively believable. The conference will have more than experts from computer science, so it knows the context, it understands the context. As well, the Indian government has allocated $1 million as a budget for the project, and so on and so on. So it is impressive how it can, as well, plenty of things get into the context. And all those algorithms were trained from scratch, in an unsupervised manner, just by downloading 1 million of text from Wikipedia and other sources. And from those texts, it was modeled a language. So it is not true that it understands the text. However, it can easily search the related parts of that. Another really impressive work, it was again from Google, in particular Google Brain Company. It was introduced a so-called capsule nets. And what it can do is that it takes actually an image and it do inverse rendering. So it describes the shapes, their position, their parameters, their rotations, and using that it is significantly easier to train from such a data. Unfortunately, it was shown that on the complex images this approach still fails. However, in 2019 it was shown that it has strong generalization capabilities and can be deployed on relatively small data sets and can perform very well. Okay, so this is what happened in the past. This is as well what happened in recent years. However, where are we trying to go with the artificial intelligence? Usually, as all the algorithms we have, it must not be only in the neural network, it can be any other learning algorithms, is that it has a vector or some degree of dimension array or matrix or something. In general, those are being called tensors, and they process the data, and again output is again vector, array, matrix, or as I said, tensor. Okay, what to do if we have a text, for example? Text is not an array. It's not a vector. Or what we can do if we would like to work as a human. Human is not understanding the world in terms of vectors. In fact, I will talk about it later. We do understand the world in a context of graphs, and we are giving the vertices and edges some attributes, and this is how we understand everything. We know everything we see around us, and it is significantly different than current algorithms and what they can do. How we approach that is usually that we are using, it was already mentioned on the first invited talk, that we are using so-called embeddings. Those embeddings unfortunately lose some portion of information. To mention some algorithms that can do that for text is the Delmo. It was introduced in 2018, or BERT, or as well the Albert, as I mentioned a few slides ago. For a graph, there are some adjacency-based similarity, or one of the best performing right now are random walk approaches that can do the transforming of the graph into a tensor shape. Well, how human perceives the world are not tensors. We have our own human internal model. How psychologists understand them is that we have so-called entities. We can do the decomposition of the world, and we can assign them attributes. For example, if something is yellow, something is of brown, for example, or any other color, magenta or anything, we can as well have relations between the entities, like the attributes as well. For example, something is smaller than something is on the right of this entity, and so on. And everything we know is internally stored in our brain in the shape of some graphs. So what we do is as well, usually during a sleep, our brain has a capability to do we have abstractions, and we can do the generalization of what we understand. For example, from the image you can see, we can say that all the metal objects are large. So this is some generalization. And with the human internal model, we have several layers and several different levels of understanding that, and trying to, with a few information, we can learn a lot. So any activity or in any problem solving can be simplified to the shape that we have a graph as an input. We process that input using our current experience. We are using actually some so-called building blocks and processes, and with those building blocks and processes, we again create some idea. It means again graph. And how we do that and why we are able to do that is that we are using a combinatorial generalization. It is the ability that has developed in our brain a couple of thousand years ago, and we have that in our prefrontal cortex. Well, why we would like to have such a capability in computers? No one of us can read in a couple of seconds several million of research papers. No one of us is able to copy the experience to another person in a couple of seconds. And in case we will be able to create an artificial general intelligence, we should be pretty close to artificial superintelligence. Then it is being said that it is maybe the last invention that humanity will need to do. And the situation is right now that we have no on a track to develop such a technology. All technology we are using and we are calling AI is actually so-called artificial narrow intelligence, and hopefully one day we will develop something like artificial intelligence, general intelligence, or artificial superintelligence that can help us with many fields and solve as well many problems. That's true that there are as well plenty of risks of such a technology. However, as well the promises and benefit of such a technology is different. What we already did when we participated on that a couple of years ago was as well the understanding of the brain on a microscopic level. On a microscopic level, we can understand the connections and the meaning of them, the connections very well. As well, we do understand on the low level how it works. Unfortunately, no any attempt so far, even the attempt to simulate the brain to a human brain, not only the fly's brain, has unfortunately failed in recent years. What is pretty impressive is that we have with birds common history. For about more than 300 millions of years, we are coming from a small fish, not very clever fish, with really small brain, simple brain, small cortex. This fish had no any capability of combinatorial generalization. And now, unfortunately, the video is not working. Well, what should be on that video is that bird that he can solve quite interesting tasks that he thinks, and he solves relatively well. What he uses is combinatorial generalization for solving the problems. Anyway, what is really interesting that after the 300 million of years, the structure of brain of birds and humans are pretty similar. So it actually is composed of parts that are related to reinforcement learning. There are parts that are related to personality and self-awareness parts. We have as well areas where memory and navigation is being stored, as well automation and motoric controls parts, and so on. And when compared the human brain to the structures of neural networks, the structures are uniform, are pretty simple, and the way to go to achieve such a technology is most probably to follow up the approach that we see that develop in the same shape in absolutely different branches. So when we compare the brain and the artificial intelligence, it is not only about the capabilities as well. When we compare the human brain, it consumes only 20 watts. It's 1 million more effective than supercomputers. It is estimated that we have approximately 100 terabytes of memory, and this all can be inside of our head. So it is 1 million times smaller than the current supercomputers. So, what the difference and what are the advantages of humans is that we are significantly much better in generalization. Those games I have mentioned already, to train them in a simulated time was taken for Alpha Zero. It was 4.9 million of games. In Dota 2, it was 180 hours per day, and right now it is not 3,500 but 4,500 of simulated games for the state-of-the-art speech recognition. It takes to train in simulated time as well 16 years. And for StarCraft it was 3 months and 180 training hours. When I compare that with the human capabilities, we don't need to have several millions of games to perform and to compete with computer. So we have, and the human brain has, significantly better ability to generalize. And looking forward that you will be the part that will put as well your effort and your algorithms to help to shift the technology in coming years, that we will someday hopefully reach the artificial general intelligence. Thank you very much for your attention.